What is an LIP? Large igneous province, which is not formed by any tectonic activity. It is not controlled by any tectonic activity. There is one place where without tectonic activity, magmatism can occur. That is your hotspot region. Hotspot region. So hotspot can occur on oceanic plate, can occur on continental plate. So accordingly, on the oceanic plate, you will get island arc, or what is oceanic island basalt composition. When continental part it occur, it is called as your CFB, continental floored basalt. So LIPs are very, it cover very larger area. So area must be greater than 10 to the 5 kilometer square. And another important thing, it should occur in lakes there 1 millennium. So the eruption must occur in less than 1 millennium. That is the characteristic of a LIP, where it is covered more than 10 to the 5 kilometer square should be occur. The event should occur in less than 1 millennium. It can occur on the oceanic plate. It can occur on the continental plate. So oceanic plate, you can say oceanic plateau basalt, OPs, or oceanic floored basalt. But in the continental part, it is called as your continental floored basalt, or you can say plateau basalt. Plateau basalt. Less than 1 million time duration. So tectonic setting. So it is occur because of deep-seated normal instability, you can say, which you can say mantle plume. Simple, you can say mantle plume. Because of this, the LIPs are formed. First, it will rise to the lithospheric plate and they will form a rift. First, they will form a rifting. That is just open fracture that will form. So, during LIP formation, the initial stage is your mantle plume will rise, and again it will form a rift. So, mantle plume will rise and form a rift, the lithospheric plate. So it will form a rift on the lithospheric plate. So that rift can be a minor rift, or it can form a divergent plate. Initially, it can be a minor rift. If it is a minor rift, then it will form a LIP. If it is a major rift, then there will be divergent plate boundary. It will be different from the LIP. So this rift, it can be minor, or it can spread through the continent. So if it will spread to the continent, it will form a divergent plate boundary. Mostly all the plate divergent plate boundary that starts with this minor rifting. Then gradually it spreads through the continent and it will form a divergent plate boundary. So sometimes these rift do not spread; they remain as minor. In that case, those rifts are called as failed rift, or we can say olacogens. These are failed rift. Understood? Plumes will rise. They will they will do the thinning of the crust, and they will form a rift. The rift can be minor or major. So during actually in LIP, the rift is always minor. So their volcanism will occur. If the leaf, if the reef will spread through the continent, then it will form a divergent plate boundary. Or if it will remain as minor like this, it will be a failed rift. You can take the example of East African rift. East African rift. East African rift is a failed rift. So rifting occur in generally in the case of rifting, it will always produce a listric fault, or we can say listric normal fault. What we say listric normal fault. First, in different stages, it will form faults which will look like a step-like structure. It will like this, both side of the rifting opening. It will look like this. You know, rifting of, you can say, of any lithospheric plate. It will form a rift like this, which is associated with this listric normal fault. Actually, these fault planes are curved. Actually, that's why the name listric is used. So the actual cause of this district, actually cause of the rifting is not known yet. In why this rifting are occurring, but this is the thing, or this is the structure here, and mostly these are always formed because of plumes. Any rifting, any continental breaking, they are always associated with a plume activity. And sometimes we can also that thinning action. That thinning action, what we say, it is always formed by plume action. And I think in the previous class I told you about the back arc spreading, back arc extension. That also do the thinning of the lithospheric plate. It's like this. Suppose the convergent plate boundary. This part is called as a mantle wedge. This part. Okay. So because of this plate motion, the mantle over it will move like this. Now this will stretch will stretch, and gradually that part will become thinner. That arc part will become thinner. Like this. This part will become thinner because of the stretching. And also, these are your volcanic part where it will rise to form island arc, and also can rise to this point also because of lateral spreading. Because of lateral spreading. It will form thinning and it will produce a rifting. So mostly those are considered associated with mantle plume, but in some case can also explain them on the basis of back arc spreading or back arc extension. So back arc spreading, or you can say back arc extension. So these are some theory what will explain the extension, but it is not also conclusive. Why the back arc is will spread, or why that will compress, or sometimes there are two phenomena key acting here. One is extension, one is contraction. During extension, these things will occur. It will form a rifting here. Understood? There main hotspot here, continental hotspot. So when the hotspot will the reach to the base of the lithosphere, it will form a keel type of structure. This is a keel type of structure. It's a keel. Then it will spread laterally like this, and it also melt this lithosphere, and it will form continental hotspot here, and it will form laterally the intercontinental zone, the reef zone, and also if it is near a back basin, it will also produce extension here, and that also fed by this volcanism from the hotspot region. This is far from these things, the oceanic plate. But we are only focusing here on the continental hotspot region, that is CFB, continental flood basalt. When it comes to petrology or geochemistry part, what are the different compositions that are, or what are the composition of the CFB? It is chemically similar to, you can say, medullary basalt or oceanic island tholeates. MRB और OIT से तो पूरा समान होती है, so chemically it is similar to MRB and OIT. Only it is more evolved. So it also contains more of anaphylis plagioclase and some additional olivine or CTX. The basalts are more hyperthin normative, so defined on the basis of hyperthin composition, and some other more bent infiled is slightly silica rich or silica over associated, where you have to represent them in quasi normative condition. Hyperthin means it mostly orthopyroxene rich. So when it is orthopyroxene rich, you have to represent on the basis of hyperthin normative. Or if it is silica rich, you have to represent it on the quasi normative. Then what are the different trace elements that are found in this setting? It consists of the incompatible trace elements such as K2O, LIL, LRE. Those are the most important trace elements, incompatible elements that are found within the CFB. They are generally enriched In the CFB basalt or controller flood basalt, and here RE pattern, it also show a similar negative slope indicating OIB, oceanic island basalt. Similarly, negative slope is like this. This negative slope indicate that it considerably undergone some fractional crystallization, because during rise of the plume, it will when it will reach to the lithospheric clear boundary, so there will be fractionation will happen, fractional crystallization will happen, and the separation will occur from the solid. So CFB pattern is most likely either it will be EMORB, that means enriched MORB, which is sometimes enriched in incompatible trace element. There are NMORB and EMRB. M will be the normal mid-ocean decomposition. So when it is enriched, it is called as EMRB. Or you can also use DMRB when it is depleted in incompatible element. If it is enriched in incompatible element, it is EMRB. If it is normal, that is the MORB, that is normally depleted. Actually, normal MORB actually not depleted. Highly depleted condition, we use DMORB. And in the RE diagram, you will find BB and BA and K. They are enriched. That will indicate the contamination of the magma with the upper continental crust. So these three elements, their enrichment will indicate they are contaminated by upper continental crust. Potassium is formed by low degree of partial melting. So during rise to the continent, due to low partial melting, potassium will be added with the magma. Barium and Pb also. These are the trace elements found in CFB. It covers this much area, the very large. There is also a LIP, you can say, large igneous province, where it cover about 1.5 into 10 to the 6 kilometers square. It is formed by when it will travel over the reunion hotspot. It moves over the reunion hotspot. Rifting will occur between Indian continent and the continent Shichala blocks. So in between these two continents, rifting occur and the volcanism occur within the Indian plate. But if you consider this Deccan volcanism in Indian plate and this volcanism in Seychelles plate, both are same characteristic, same age. So that's why it is considered that these two plates are together in that time, and due to the reunion hotspot, the rifting will start, the minor rifting will start, then volcanism will occur, then they will parted out. So it is during our Cretaceous, during our end of the Cretaceous, approximately 66 million years. So they now cover 1.5 to 10 to the 6 kilometers square in India, where it thickens toward the west side. The Sahyadri range, Western Ghat, near the coast of the Mumbai, is about 2 kilometers thick. The lava flow is 2 kilometers thick. Volcanism also spread because it is I think it is the most largest volcano on earth. It spreads towards the south up to Kerala. Also, it has some traces into the Andhra Pradesh. So because of the low viscous, it spreads most of the you can say western part of the India, western to southern part of India, and also it covers from western to central part of India. So that's why it is very large. So all the lava they erupted in less than 1 million years. So they erupted in less than 1 million years, and they have a extent of 1.5 into 10 to the 6 kilometers square, which that's why they are considered as alive. So these are the geographical condition of Deccan Trough. It has also features within the Indian Ocean. And what are the different characteristics of meteorological criteria of Deccan Trough? So mostly Deccan Troughs are tholeiitic lavas. That is, if you plot it on any task diagram or any AFM diagram, you will get like this. This is your basalt. This is your Deccan Trough. This is sub-alkaline. This is the line that divides in task diagram alkaline and sub-alkaline. This is the region where it will fall in basalt or basalt andesite, which is completely tholeiitic characteristic. See also here in the AFM diagram, if you plot basaltic composition, it will also show tholeiitic composition. Take as many as sample, they will fall within this area. So mostly those are tholeiitic. So major mineral constituents from olivine, pyroxene, plagioclase, you will find very large grain of plagioclase, up to 30 mm size. And you also get Fe-rich titanium oxide. So Mg is generally less than 60%, but if you have picrite, they can reach up to 80%. The trace element, they show a greater variance. If you take MgO percentage, here the MgO percentage will be less than 8, greater than 8%. MgO percentage always greater than 8, and approximately it reach up to 25% MgO percent. So only all the parcel from the Deccan Trough, all the flow from the Deccan Trough, approximately 10% will find in alkaline condition, or all other below the alkaline, that is in sub-alkaline basalt. That is here you can see. Some may touch to the alkaline line or may fall beyond the line, because the sample they are taken here all are sub-alkaline. Some sample may show alkaline condition. So here tomorrow, tholeiitic basalt were derived from the upper mantle, like that is a mixture of reunion hotspot and NMRB source, plated NMRB source. When these two will mix, they will form a tholeiitic basalt condition. In case of Deccan Trough, they are not having a contamination with the upper crust. They are not with any metal that not added from the upper crust. That's why tholeiitic character is preserved during volcanism. Also, you can say it is sub-alkaline. If it is added with upper crustal, it may become alkaline. Another important thing, it shows high value of He3 and He4, which always indicates a deep mantle source. This ratio, if it is high, it is always indicate a deep mantle source. Obviously, the source of the male will be gone. Mantle plume heat because it is hotspot region, and mostly they are thallitic in character. So these are the petrological criteria or geochemistry criteria. You can also add other thing like what will say structure, columnar structure, pile structure. That you can add another thing, or you can also add about the different flows. That is lava flows, interturban bed, infraturban bed, interturban bed. So you can add all these things also. So depending upon the question, what is the value of the question is it 5 marks or 10 marks. ଯେତିକି ମାର୍କ ଥିବ ସେ ଅନୁସାରେ ମୁଁ ଆଡ୍ କରିପାରିବି. That part will study in case of stratigraphy, in case of structural igneous form and structure. All this will be covered in there. So during your ascent of magma, it can solidify within the surface or in the subsurface region. So some structure they will follow the strike of the bed or follow the structure of the bed, like if they are structurally controlled, or some they will cross cut the structure, they are not structurally controlled. On that basis, we always divide the intrusive body into two types. One is your concordant, and another is your discordant. So, so what is the concordant? Where the structure or igneous intrusive form that is horizontal, that is concordant. So whether we will use the word concordant in case of concordant, or whether we will use the word horizontal, or you have to use something else. Whether concordant structure are always horizontal or not. Anyone? Concordant means you have to use the word any more igneous forms or intrusive forms that is parallel to the strike of the bed. It is coincide with the strike of the bed. So anything that coincide with the bed or parallel to a bed, that is also concordant. And discordant any that cross cut the strike of the bed, that is either perpendicular or at any angle with the strike of the bed, that will consider as a discordant. That means the concordant structure can be vertical if the bed is vertical. So discordant structure, the concordant structure can be horizontal if the bed is horizontal. So always depend upon the attitude of the bed. So that there are different structure. These are dike, it is discordant. Cone sheet, discordant. Pathway, both. Cells, concordant. Lacolith, concordant. Locolith, concordant. Bismullith, discordant. Facolith, concordant. Structure. I will only discuss the important ones. There is intrusion, there are concordant and discordant. Lacolith, locolith, seals, facolith, salt domes. Then dikes, batholith, stocks. Batholith is larger, stocks is smaller. That is the only difference between them. Then volcanic necks and volcanic pipes. The dikes are discordant bodies. So take that cross cut the pre-existing rock, as you can see here. It is cross cutting the pre-existing rock. These are also some figures you can see where it is cross cutting the contour rock. So it is a composition, you can say doleritic or basaltic. There is a composition of doleritic or basaltic. So the thickness of the dike, it can vary, so from feet to many hundreds of feet. Thickness can vary to very more smaller thickness, that is 1 feet or 2 feet, to many hundred of feet. Also, length also vary. During for structural failure, you always find this dike and you have to trace the dike. So because it has a very great extent, that means the lava or the magma that it is formed, it should be more mobile. It should be more mobile so that it can spread to a greater extent. So dike may occur as a, no, no, a single intrusion, or it's from most of the time it occur as a system, or what we say dike swarms. When the number of dike is larger, then we use term dike swarm. So obviously occur where there is a fracture or crack that occur because of the tensional force. Understood? So dike. These are other figure. Dike always characterized by another thing, that is this shield margin. This characterized by shield margin because during intrusion the dike will be hotter than the surrounding contract. Hotter to the surrounding contract. When it comes in contact with a colder contract, the margin will suddenly cool. The margin will suddenly cool, where there will be no crystallization, glassy texture will be found. That is called as chilled margin. So it is the characteristic of, you can say, both seal and dike. Both seal and dike, chilled margin. Then it can also produce for reaction rings. The ring-like structure you already studied in texture. Then come to another the discordant structure, that is your cone sheet. So cone sheet occur when usually we say there is a greater pressure of magma than the lithosphere. So suppose this is the magma region, this is lithospheric region. So lithosphere is putting pressure on the magma, and magma is also upthrusting. So when the pressure of the magma is greater than the lithospheric pressure, then the magma will able to break this lithosphere, or can form a fracture within the lithosphere where magma can squeeze out like this. So this is how a cone sheet will form. This is how a cone sheet will form. So ascending magma that will uplift the contour, and magma will move like this. So it will form a cone type of structure, that will say cone sheet. So mostly, approximately, these cones are tipping at an angle of 30 to 40 degree, approximately. They all dip towards a common center. They all do dip towards a common center. That is also characteristic of the cone sheet. They will be like this. Okay. They all will dip to a common center like this. This is a magma chamber. The very small size is smaller. Cone sheet size is smaller because of, and it is formed because of forceful injection. There is forceful injection because of the more pressure of the magma. So that means here magmatic pressure is greater than the lithostatic pressure. Then also batholiths. Batholiths are very large intrusive body. So when it is the intrusion or the intrusive body, when it is greater than 100 square kilometer, it is considered batholith. If it is less than 100 square kilometer, it is stop. 100 square kilometer अधिक हेले ताको batholith कहते हैं. Less than 100 square kilometer it is called as stop. So batholith, these are, you can say, they consist of granite and granodiorite, the composition. Because of this, they have less mass, and batholith always show a negative gravity anomaly. कौन देखे? It shows a negative gravity anomaly. These are batholith. So it can be concordant and discordant. bathylit ta kon pare, maybe concordant he pare, maybe discordant he pare. So as you go to depth, the extent of the bathylit increases. As you move down along the bathylit, the lateral extent of the bathylit always increases. Normally, batholiths are found in orogenic belts. Orogenic belts basically, and it is both concordant and discordant. So in shallow depths, these are discordant. In shallow depth, these are not discordant, but in greater depth, it is concordant. So in shallow depth, these are discordant. In great depth, they are concordant. So after the emplacement of this structure, they expose to the surface with exhumation process or erosional process. So when they expose to the surface, they may expose in a irregular fashion or may be exposed in a regular fashion. The exposure is irregular, it is called as your stock, which has a area less than 100 square kilometer. If the exposure is circular, it is called as your boss. The boss and stock. Understood? The composition mononuclear, that is granite to granodiorite, negative gravity anomaly, and occur in orogenic bed. And the dimension of the intrusion that increases with depth. Long question may have to add those points. Normally it is a simple thing: granitic intrusion, negative gravity anomaly, and it has to extend more than 100 square kilometer. Boss, it is also exposure part. Both are exposure part of the batholith. When batholith exposed to the surface by erosion. Stock is a very irregular exposure, which doesn't have any shape or size, and boss has a very circular outcome. That is the only difference between stock and boss. Both are exposure of batholith. One is circular exposure, one is irregular exposure. So the stocks. The volcanic neck or what we say volcanic block structure. When it will expose to the surface, those are called as volcanic block. It is called as volcanic floor or lava neck. So it is simple when volcano that consolidated within the vent. So that is called as a volcanic neck. So after exposure, after erosion, it will expose to the surface like this, and those are very resistant structure. They are very resistant to weathering. अगर बहुत अधिक weathering resistance है, so alkaline igneous rock typically are associated with this type of structure. So silts are concordant bodies that follow the altitude of the bed. So it is also toleratic or basaltic in composition. And in case of seal, it spreads to the weaker section of the rock, weaker section of the bed laterally. Because of this high mobility, it can spread to a larger area. And important thing which is here, the supply of magma from the magma chamber. Taking magma to supply way and the spreading rate of the seal. So here the spreading rate of the seal is always greater than the supply of the magma. It is because simple of its mobility. So it is associated with basic magma. So the more mobility, that means it will extend to larger or extend laterally to more area. So it also shows gel margin. mostly composition basaltic or tolerating. Mostly the seals are found in you can say key sandstone, mostly along sandstone, or you also found in coal seal, mostly in sandstone, and also in case of coal seal you found seal. Then laccolith is an inverted bowl-like structure. It is an inverted bowl-like structure that occur if relatively higher viscous magma intrude into the content rock. So in that case, it will exert pressure and form a dome-like structure with a flat base. It is called as your laccolith. So here, because of the high viscosity, magma cannot spread laterally to a greater distance. So that's why they will move vertically. If this viscosity is more or it will increase, then it will intrude like this. It will intrude like this. So in that case, it will consider as a discordant body, and it will call as a bismullite. It is called as a bismullite. So bismullite actually formed from the laccolith, and the laccolith is more viscous. So lateral spreading is very less, so that it will always try to move upward. Then lopoliths. Lopoliths are larger than laccoliths. So lopoliths are basin shape or saucer shape deposition. They always consist of layered intrusion. They always consist of layered intrusion. These are called as LMI, layered mafic intrusive. They are called as what? LMI, layered mafic intrusion. So lopoliths are much larger than the laccolith. Laccolith ର ଯେତିକି size ଥାଏ, lopolith ଠାରୁ ବହୁତ ବଡ଼ ଥାଏ. Lopolith are much larger than laccolith. They consist of layers of contrasting composition or different mineralogical composition you find. Locally, sometimes it look like a champagne glass. Look like a champagne glass. The locally is always also called as champagne glass structure. Champagne glass structure. देखिस तो the laccolith and locolith. Then comes the faccolith. Faccolith which it is the form in folded region. The lens side shape, concurrent bodies. Composition also basic. There are different structures: seal, dike, stocks, bathylis, ring dike or radial dike. This is a ring dike. So ring dike forms when magmatic pressure is less than the lithostatic pressure. In that case, ring dike will form. There is a circular outcrop. Volcanic lakes, the seal, dike. This is a bismullite, where it is more viscous than the lopolith. Lopolith, laccolith. It is more viscous than the laccolith. Then constitute a different form structure, that is your vesicular amygdaloidal structure, that is on the surface. Then magma erupts to the surface. So all the gaseous substance they will release, they will form vesicular structure. It is called a vesicular structure when all the gases from the magma are released, because they are at a depth as a all the volatile matter they are present in solution because of pressure. Like you can think of a cold drinks bottle. So if you open a cold drinks bottle, then bubbles will form. because the carbonates they are within the that beverages within that beverages in soluble condition because of the pressure. So volatile can be in soluble condition within the fluid in high pressure condition. If you release that pressure, then they will escape. So when they will escape, they will form bubbles. So that is your vesicular structure. चौकुली पिठा खायचं ना नाही? चौकुली dosa. Dosa ला जो hole है, that is because की all the water that will escape and it will form a vesicle structure. Similarly, that happens in case of magma or lava. When it will come to the surface, all the pressure will decrease because of the volcanism, and all the volatile matter will escape. When they escape, the gas will escape. They will leave the empty space. That is a vesicular structure. And that structure, when they will deposit on the surface by surfacial process, that the opening space is filled by sediments are filled by minerals or secondary deposition, that is called as your amygdaloidal structure. That is the secondary infilling of the vesicles. So the different minerals, secondary minerals, they will fill the depression. So that you can say calcite, quartz, geolite. So they are the secondary mineral. They help in infilling of the vesicles, and also they collectively called as green earth mineral. Also collectively called as green earth mineral. Secondary entry minerals are collectively called as green earth minerals. Then another structure that is lava drain tunnel. That is because the upper part of the flow solidifies faster because it is come in contact with the atmosphere. The lower part is still in molten condition, so that will flow and will form a tunnel-like structure. That is called a lava drain tunnel. Then blocky lava, it is also called as AA lava. So it is viscous. It is viscous. So blocky lava, it contains more, you can say, water content than the rocky lava. So when all the volatile that escape, the blocky lava will form vesicles. Those are very large. They are very large. And when they will solidify, they will form a very rough and jagged surface. Irregular or rough and jagged surface. So it has a acidic composition. That's why it has a high viscous and it solidifies near the vent. It will solidify near the vent. It cannot go more distance. So sometimes these blocky lava, as it is acidic, they actually come from lesser depth. They actually come from lesser depth, then they directly affected by the directed pressure of the lithostatic. So they are under direct lithostatic pressure. So when the lithostatic pressure will release and volcano will occur, all the gaseous substance they will release at once. So that's why during more acidic volcanism or blocky lava, the violent type of volcanism where there will be more, you can say, sound, and magma can thrown out to a greater distance or can thrown out to the air to a greater height. So अधिक height from the जाइए because they are very catastrophic because they are under direct pressure of the lithostatic, they are the direct pressure of the lithosphere, and when to release because of their high volatile content, they all will make more sound. It is also similar to, you can say, cold drinks bottle. When you open the cold drinks bottle, it also makes sound. Okay, when the gas will release, it will make sound. So, but because of this blocky lava has more volatile content. So, at the initial stage, you will say blocky lava is more mobile than rocky lava. but the volatile they escape so quickly, then it became more viscous. Ropy lava. The basic composition can spread more. Surface is smooth, like unlike the jagged surface in case of blocky lava. So it also contain vesicles, but the vesicles is smaller. In case of ropy lava, the vesicles is smaller. Unlike blocky lava, they are larger vesicles. Ropy lava has smaller vesicles, but they have numerous vesicles. The smaller and numerous. So it has kind of the small and numerous vesicles, but blocky lava has kind of larger but less numerous vesicles. So these, in case of ropy lava, these vesicles are very regular shape. But ropy lava, they have any regular shape vesicles. They have very regular shape vesicles. So there are some difference between, you can say, ropy lava and blocky lava, and another difference which is in case of ropy lava and blocky lava, the FeO by Fe2O3 is always greater in ropy lava than blocky lava. Ferrous to ferric oxide. The ratio between ferrous to ferric oxide is always greater in blocky lava, always greater in ropy lava than blocky lava. It is always greater in ropy lava than blocky lava. So pillow lava that contain characteristic is more pillow shape, and most importantly it occur in water cloud condition or underwater condition or marine condition. So because of exchange of iron with the marine water, those lavas are always richer in sodium content. So that ये pillow lava always has a Na rich magma. That is we called spillite. That is your spillite, Na rich composition or a spillity composition, because it exchange with the magma chamber of the ocean water. So when ocean water exchange magma with magma chamber, it's richer in Na content. So pillow lava may contain more glassy debris, what we call hyaloclastite, produced from fragmentation of hot lava. So it debilifies and form an material that called palagonite. So when a pillow lava will form, same condition, it will come in contact with the water, then the upper surface will suddenly will solidify. But inside there always fluid present, or there always molten metal present. So they eventually they will force out their way and form another bubble like this. And again same process will repeat and they will form a pillow-like structure. Then the most Igneous structure can also form in sheet, platy, and columnar. Columnar it is because the lava flow that because of contraction to a common center during shrinking of the or during cooling of the lava flow. This columnar structure which is characteristic of the basalt. Sheet structure it is because formed because of the erosion or release of pressure by erosion. When superficial the weathering or erosion happens, that will release the pressure to the subsurface rock. They will relax to form sheet structure. And similarly, also platy structure. Uh, Like different sets of joints produced. The mechanism of, we can say, columnar basalt. Platy structure and columnar structure. So what is Boninates? It is an unseen andesite. You can say it is an unseen andesite. So andesite it is intermediate characteristic not intermediate in its form in subduction zone. So during for ancient time, this andesite was boninates. The main difference between these two is the MgO content. Andesite has a low MgO content and boninite has high MgO content. So boninite is a fine grained igneous rock. There is abundant orthopyroxene, phenoclist or macroclist, but with no plagioclase. Plagioclase name with silica content. There is no plagioclase present, but they have high silica content. You can find 50 to 52, 55% of silica content within boninates. So it is obviously formed in subduction zone. So it is the name is given from Bonin Arc of Japan. So it is more considered as a primitive andesite that derived from melting of metasomatized mantle, or you can say secondary or second phase of melting of lithosphetic plate in subduction zone. Region in case of second phase of melting. So that's why it is characterized by extreme depletion in incompatible elements, because it is formed by second phase of melting. In first phase of melting, all the incompatible element will be erupted. In case of second stage of melting, that's why they are extremely depleted in incompatible element or trace element. So they are found almost exclusively in 4R primitive island. Only in 4R that should be primitive. That close to the ocean tree. Also, you can find in ophiolite sequence. In some ophiolite sequence, where your wearlite, boninite, there you can find also more boninite composition. The high magnesium content, MgO approximately equal to greater than 8%. Low titanium condition, that is TiO2 less than 0.5%. Silica content is 52 to 63%, which is almost acidic condition. High Mg by Mg plus Fe ratio. The nickel, chromite, these are compatible elements present here. Barium, strontium, LRE enrichment compared to thoilite. Though it has got more barium, strontium, and LRE component. And also you will say titanium zircon and lanthanum ytterbium. The ratio in between here it will show 23 to 63, and it is ratio 0.6 to 4.7. So just remember those are very highly depleted in case of trace element or incompatible element. How it is formed? The most boninite form at the second stage of melting of 4R vessel. So during convergence, is specially they are formed because of this mantle base. This portion it is called, this is a triangular portion, it is called mantle base. It is the mantle above the subducted slab. They also induce melting here. So these are form the hydration of previously depleted mantle within the mantle base above subducted slab, causing further melting of the already depleted petroleum. So during you can say we have studied in case of mantle metasomatism due to rise of the plume, so they will hydrated those parts. So after one stage of melting, due to rise of mantle plume or due to rise of magma, so those part again they will hydrated. You can say this part again they will hydrate it. When they will again hydrate it, they will start melting because the melting temperature will decrease. So now the melt will form here. They will extremely depleted in trace elements. So that type of rock that formed by the second stage of melting, it is will form a boninite. So that's why 4-arc environment is ideal for bonite formation. Can also found in say the back arcs. So they keep to the extension which is in back arc extension. You also find boninite composition or deposition. So titanium is very less here. That extremely low because because of it is a second stage melting. The titanium is always removed in the first stage of melting because it is incompatible. So during the first stage of melting, it will form andesite. That is your island earth basalt composition. During the second stage of melting, it will produce boninite. So it is always required more of it is high magnesium because because it is formed in second stage with a high degree of melting, high degree of partial melting. That's why magnesium richer and very low in titanium content. And this in this case, for melting occur because of the hydration, because of the addition of volatile during for mantle metasomatism. During mantle metasomatism. So these are the conditions that written here. Okay, how it is formed. So sometimes it is enriched in barium and strontium during for which is derived from the oceanic crust. Also, we can find evidence that borinates that derive from pedotite, that depleted pedotite, but it is sometimes enriched in LRE because of mantle metasomatism process.